Hey everybody. Today I will be going over Learn Target 15 again, the from Checkpoint 8, your second attempt on it, just because it's a core learning target and I really want to make sure you guys get a lot of exposure to it before the final attempt. So this learning target's all about finding critical numbers and then determining the absolute extrema of a continuous function. So the steps to it are all pretty similar, but it's a very important thing that you'll use in future classes like physics classes and higher math. So it's good to get a good foundation of it. So we need to find the critical numbers of this function, f of x equals x to the fourth power minus 2x cubed. I threw in this little note here. Remember that the critical numbers must lie in the domain of the function. So just looking at this function right here, I don't see any square roots and I don't see any denominators. So that pretty much indicates to me that this little note won't be an issue. It wasn't really given in the first place, and it was given to you in checkpoint 7 because that involved the denominator. So just keep an eye on that. Remember to test your potential critical numbers to make sure that they're in the domain of the function. All right, that's a little sidebar, but we'll hop back into it. So the first step of finding a critical number is to take the derivative, f prime of x. In this case, using the power rule, we will have 4x cubed minus 6x squared. And then, as always, we want to set that equal to 0 because we're looking for the points where the slope is equal to 0 because that means the function might change direction. All right, let's see what we could factor out. They're both even coefficients. I can factor out a 2. I can also factor out an x squared. And that leaves me with 2x minus 3. Still set equal to 0. And from here, I have two different expressions that equal 0. I have 2x squared equals 0, and I have 2x minus 3 equals 0. So from there, we can determine that x equals 0 is a critical number, and x equals 3 over 2 is a critical number. So I'll just write that here. Critical numbers we have that x equals 0 and 3 over 2. All right, next we need to find the absolute maximum and minimum values of f of x on this given interval, -2 and 1, or -2 to 1. So you'll see that it's closed brackets here. That means those are included. And since we're looking for absolute extrema, we can consider those values as potential candidates. We need to make sure that we're only caring about this interval. Notice that little note there. Oftentimes when you're doing these checkpoints, if you see a little note italicized, it's probably pretty relevant. When I look at my critical numbers that we solved for up here, I see that 3 over 2 does not belong in this interval. So we can throw that out. So that means our candidates will be x equals 0, because that's what we solved for earlier, and then -2 and 1, because those are the endpoints. All right, now we want to check all of these candidates, and we want to check it in our original function, x to the fourth minus 2x cubed, because we're looking for the absolute max and min of f of x, not f prime of x, but f of x. All right, we'll start with f of 0, where x equals 0. And that is going to be 0, because 0 to the fourth minus 2 times 0 to the third. 0. Then we have f of -2, so it'll require a little bit more work. I have -2 to the fourth minus 2 times -2 to the third. I always kind of harp on this in these videos, but I really suggest using parentheses, especially when you plug in negative numbers in terms of exponents. If you don't include those, especially with your odd powers, you can make mistakes. Because like -2 cubed, or sorry, I meant with your even powers, you can really make mistakes. and odd 2, I guess. So I have negative 2 to the fourth. This will just be equal to negative 16 because that negative is not attached to the fourth. Compared to negative 2 parenthesis 4, you're also raising that negative to the fourth power. You end up with a positive 16. A little sidebar there. Most of you guys probably already have a good foundation of that, so don't let me confuse you more. But for those who don't, just use parentheses. It'll save you a lot of time and trouble. All right, so negative 2 fourth. I already kind of talked about that. That's 16 minus 2, and then negative 2 cubed. So negative 2 times negative 2 times negative 2. That's 4 times negative 2, which is equal to negative 8. Alrighty, this will be equal to 16 plus 16, which equals 32. And now we need to solve for f of 1, which just equals 1 to the fourth minus 2, 1 to the third. That's just plugging in of 1 minus 2, which equals negative 1. All right, so we got our values here. We determine the max and the min. So I'm going to say that my absolute max on this interval is equal to 32. And that occurs at x equals negative 2. 32 is the biggest number we get, and it's associated with negative 2. I'm also going to write that the absolute min is equal to negative 1, and that occurs at x equals 1 from right here. Okay, that's our answer. Just one more little summary. When you're finding critical numbers, you're going to take the derivative and set that derivative equal to 0, and then solve for the values of x that satisfy that equation. And you're going to make sure you remember that critical numbers must lie in the domain of the function. In this case, we didn't have any square roots, we didn't have any denominators, so it's not too big of a deal. But in the case of square roots and denominators, just take an extra second, make sure the numbers you find are in fact in the domain, and then you're good. All right, now we need to find the max and min values on an interval. Remember that you only care about values in this interval. That means we can scratch 3 over 2 because it's not in this interval right here. And when we have candidates for max and min values, we need to include those endpoints, negative 2 and 1, because these brackets are closed. They're on the interval. And from there, we plug in our candidates into the original f function, f of x, not f prime of x. And then we'll get our values, 0, or in this case, 0, 32, negative 1. Find the highest one, that's your max. Your smallest one, that's your min. Specify those, and it's also just good practice to tell where they are, like what x value, x equals negative 2, x equals 1. I didn't specifically ask for it in this case, but it really shows you that it really shows like the grader that you know where it's at, what you're talking about. All right, well, I hope that's good help as you guys study for the third attempt at the starting target. You got it.